Lesson 109, corresponding parts, similar figures, a little bit longer lesson, so stick with me here. Really be thinking about what we're learning so that you don't have to watch it twice. Corresponding, is that a word you've used? Do you know anything about that word? Think about it. What's corresponding mean? Maybe one example would be, your left hand corresponds to your right hand. They look kind of the same. They're very similar in what they are. Your textbook corresponds to other textbooks. They all match. And we can break that down even further. The second page is the corresponding page to the other book's second page. There's certain parts that correspond to each other. Your right leg corresponds to another person's right leg, maybe even better, because they're both right legs. Correspond, they match up, matching up parts. I should probably say that. Similar is going to remind us of the word congruent. What did we remember the word congruent meant for shapes? Congruent's when it has the same size and shape. Similar is going to be only one of those, and it makes some interesting problems. First of all, corresponding parts. The two triangles below are congruent, ABC, XYZ. They have 3 angles and 3 sides each. If they're congruent, all those 3 have to be the same. The only difference, of course, the way the triangle's sitting and the letters. So you could say A corresponds to X, B corresponds to Y, and such. Line AB corresponds to side XY. But that might not always be obvious because they're sitting differently. You might want to say that ZY matches with AB because they're the ones on the ground. But we're trying to match up corresponding parts that are the same size. In two figures that are congruent, their corresponding parts are congruent. So the measures of the corresponding parts and congruent are equal. That can help us with something like example 1, where we're missing a side, and we'd have, right now, we don't know in our course 1 study how to find the length of this last one. But if we know that this triangle is congruent in all ways, we can rotate our triangle up, and then no need to translate it. We're just able to look then at a triangle that looks like this. The 90-degree angle was brought to the other side onto the ground, so to speak, on the pivot point between 3 and the unknown. So 3's down here, 4 was the height, and we're finding this one. 5 is that side, that hypotenuse on the other triangle we know because they're congruent. And it asks, what's the perimeter? Well, 3 plus 4 plus 5, 12. Of each, that part's kind of a trick you don't really need. If they're congruent, same sides, that means they're both 12, right? 3 plus 4 plus 5. So we used a little bit of our transformation skills and logical reasoning to deduce the side that's missing, and then adding up for perimeters. The perimeter's distance around all sides added up. Similar, I said, is going to be like congruent, but the same shape may not mean the same size. Therefore, the sides might not be the same. Like, this does not equal this. This is much bigger. Triangle 3's height is bigger. But they are the same shape, so they have a very close relationship to each other. These sides are not all the same. But, well, these ones are congruent, but these ones are simply similar. This one will never be similar because I don't think there's a right angle in there. It just doesn't look like the same triangle at all. So not all the triangles will even be similar. But similar means there's a little bit less in common as congruent. Just the same shape, not the same sizes for sides. If these two are similar, what's the angle of measure A, you think? We can rotate and reflect this so that it's standing up like that, and we had a 90-degree angle. Oh, yikes. We had the 90-degree angle right here. we've pivoted on and then flipped. That leaves me with a 30 here and a 60 here, and A matched up with this one. So A is 30 degrees. This is because a truth about triangles, the corresponding angle of similar polygons and triangles, those are all congruent, even though the sides might not be exact. But then the sides are proportional. Similar figures are related by a scale factor. The scale factor is a number. Multiplying the side length of a polygon by its scale factor gives the other side length, the corresponding side length for the similar polygon. Example 3 says the two rectangles below are similar. So not the same size, but the same shape. We can build a ratio, a comparison top and bottom number for corresponding sides for rectangle ABCD and EFGH. First of all, let's figure out, are they oriented the same? What's the corresponding parts? I think BC looks to match up with FG, or EH, but it doesn't matter. Okay, and then AB matches up with EF. Those are corresponding sides. Side AB was 2. Side EF is 1. We could have also done BC over FG. In both cases, we find scale factor is 2. Call that the scale factor. It's the multiplier that tells us everything we need to know, especially for lines and perimeters and things. So you just match up the lengths of the corresponding sides as a ratio, and that's the scale factor. The sides of rectangle ABCD from the left was 2 times larger, double the sides of rectangle EFGH. So rectangle ABCD is larger than rectangle EFGH by a scale factor of 2. All angles are the same, right? What are the angles of rectangles? 90 degrees, no matter the size. That's why that's the case. Letter A, are all squares similar? All squares are similar. True or false? I would say true, because all the sides are going to always be the same, and the angles are always going to be the same. They're not always going to be congruent. All similar triangles are congruent. True or false? Similar meaning same shape, different sizes. Well, then they can't be congruent. They can, but they won't always be. Plenty of triangles aren't. For example, you look down at example lesson practice E. Here, there's several triangles here are not congruent, but they might be similar. Letter C, if two polygons are similar, so they might not have the same size, but they are the same shape, and there's a proportional relationship, then their corresponding angles are equal in measure. True or false? I believe that's true. I think we learned that earlier on this page, right here in the middle. Number 1, corresponding angles of similar polygons are congruent. If two polygons are similar, our corresponding angles equal. Equal, congruent, kind of the same thing. Why don't you do D, E, and F? F kind of looks like home plate, doesn't it? I know you can do it. Work hard, ask questions.